Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. In the NEET examination series, we are going to discuss today about D and F block elements. So, NEET examination is so close to us. So, method, get ready. So, we are coming with a chapter and a topic wise in everyday sessions, and we are giving NCERT line by line series. So, when you see the question paper of the NEET examination since a few years, you can find direct NCERT line by line से question निकाल के आपको देना हो. And we framed such a questions and giving of the best and get ready. So, we are going to discuss the concept as well as questions and neat and very worthy points we'll discuss. Hi, life is chemistry. Good afternoon. How are you? So happy to see you guys. So board examination series को मदद दिया, NEET examination series अभी चल रहे हैं, and get well prepared for your NEET examination. Before going for that, those students who are online, please like the session, share with your friends, and subscribe to Infinity Lens Sri Chaitanya Academy YouTube channel. Right? So this is a very important point. We are going to give you about the transition elements, and take a pen and paper, write the noteworthy points, and if you have any academic doubts, use the chat box with a lot of decorum and we can start the concept. Fine, I am fine, thank you. Mohan, good afternoon. Very good. So in the transition elements, this is your periodic table बच्चों. इस periodic table में these are called S block elements, P block elements and D block elements and F block elements. आज हम चर्चा करने वाला है ये वाला. And in that you see the D block elements, the elements in which the d orbitals are filled are called D block elements. They are also said to be transition elements. हर D block element transition element नहीं हो सकता, लेकिन हर transition element D block हो सकता है ना. That's a tricky point बच्चों. इसमें scandium to zinc 3D orbitals are being filled. And you say ytterbium to cadmium 4D orbitals are being filled, and lanthanum to mercury 5D orbitals are filled, and actinium to cuperancium 6D orbitals are filled. You need to know which orbital is being filled. So this is what you say: first transition series, second transition series, third and fourth transition series. And usme you can see you have to spot out this. Zirconium and hafnium has similar properties Lanthanoid contraction के हिसाब से. So for that I just want to give you very important points, right? And you see zinc, cadmium, mercury, these are not considered as a transition elements. Transition elements starts from there and ends here. So I'm from Infinity Lane YouTube channel Sri Chaitanya Academy से, Hyderabad Central Office से. Okay, life is chemistry 547. So thumbs up and fire emoji. आगे बढ़ने तो क्या D block elements, the elements in which the D orbitals are filled in the penultimate shell are called D block elements, and general D block elements are called transition elements. And because they have incompletely filled D orbitals, they are in the transition between S block elements and P block elements, जिसका property है ना, ये दोनों का अंतर में होगा. And they are all metals. Transition elements का जो condition होता है क्या? They should have incompletely filled D orbital either in the ground state or any stable oxidation state. You can see iron, they have incompletely filled D orbitals. You can say iron 3 plus Ba. So incompletely filled D orbitals. Either in this case or in this case, you can identify the existence of vacant or incompletely filled D orbitals. F block elements are the part of the D block elements. So they are said to be in transition elements bachcho. And learn the things with us. Okay, definitely you are going to learn. And since last we can say it is March 9th, almost a week less 2 months, right? So in that last 50 days or so, If still you have not properly started NEET preparation, you can think and you can seriously think and you can seriously work. I can assure you definitely you are going to clear NEET examination. मैं मजाक से नहीं बोल रहा हूँ, सच में बोल रहा हूँ. द विल पावर एंड द सिंसियरिटी ब्लेंड कर पे आगे बढ़ो, अच्छा होगा बेटा. डू यू एग्री विथ मी? Do you agree with me? Right. Now, in that you can see it is a cerium 58 4f1 hai dekho. So, always you see when the electrons are being filled, okay, s orbital and p orbitals are filled in the ultimate shell, last shell. D orbitals are filled in penultimate shell, so last but one shell. F orbitals are filled in anti-penultimate shell, last but two shell. है ना बेटा? And these are inner transition elements are also called as F block elements. In that anti-penultimate shell में 4f orbitals will कर सकते हैं. Non-transition D block elements. In this zinc, cadmium, mercury, they are said to be group 12 has completely filled D10 configuration. They don't have incompletely filled configuration, either in the ground state or any stable oxidation state. They are said to be non-transition D block elements. Which of the following is a transition element, which of the following is not a transition element? Like that questions you are going to experience it. So zinc you can see 3D10 ground state में, zinc 2 plus फिर भी 3D10 आ रहे हैं. Zinc, cadmium, mercury are not considered to be transition elements, and silver is a transition element क्योंकि silver D10, silver plus D10 and silver 2 plus D9 है. So you can consider silver as transition metal. Simple questions will be asked, and you can see transition elements, you can see the position, periodic table, general properties. फटाफट कर देता हूँ and ताकि आपका questions भी निकाल सकता हूँ. समझ में आ रहा है क्या बेटा? अगर कुछ डाउट है ना तो you can ask in the chat box and we can discuss here. So you can see n minus 1 d 1 to 10, ns 1 to 2 is the general electron configuration, or otherwise n minus 1 d 1 to 10, ns 0 to 2 भी possible है क्योंकि palladium you have S0 configuration, 5s0 4d. Okay, so that this is also possible. NCERT में periodic table में ऐसे दिया, D and F block में ऐसे दिया, so दोनों valid है. Okay, last electron enters in the d orbitals. Now these are the various electronic configurations. You can see अगर कुछ doubt है ना तो आप सीधा पूछ सकते हैं बेटा. Fine. Now moving ahead, manganese, maximum number of unpaired electrons are present in the d orbitals बच्चों. n minus 1 is called penultimate shell. Sunshine creations. I observe every chart during the class. I honor if you have any doubt. Fine beta, that's good, fine. And transition metals exhibit certain characteristic properties. जो भी properties है ये एक ही reason होता, due to their vacant d orbitals, due to unpaired electrons. So let us see the list of the general properties, atomic properties, chemical properties, and NCERT जो textbook में दिया हुआ ना, जो information के हिसाब से, एक graphs भी हिसाब से आपको रीजनिंग क्वेश्चंस ज़्यादा आता है. NCERT is the basis of the total examination system. That is the fundamental rule. And I wanted to say, based on this NCERT, directly in the NEET examination, you are going to get 2 questions from the D and F block elements. 2 questions, 8 marks will be yours. Believe me, ये सच बात है. And you can see physical properties. All the transition metals display typical metallic properties. So what are the typical metallic properties? They have high tensile strength and high thermal and electrical conductivity, malleability, ductility and electrical conductor, hard and less volatile, because you can see this is what is called high tensile strength. So high thermal conductivity, high electrical conductivity. मजा आ रहा है क्या? So you can see these presentations so that you can memorize the things, and they are ductile and they are very hard and thin, can be drawn. Okay, so thank you very much. Thank you. Please, those who are online, please like the session. Okay, Mohan, come on, let us see the more things here. High melting point and high boiling point, these are all the typical metallic properties beta. Okay? And melting point of the transition metal. Melting point transition metal is because of the involvement of greater number of d electrons in participating the metallic bonding. So interatomic metallic bonding, they have both covalent properties as well as metallic properties. So general rule, greater the number of unpaired electrons, stronger is the intermolecular force, higher is the melting point. So that is the fundamental rule. So use the general rule, no exceptions, and if you have an exception, paper setter will ask question there itself. We are going to discuss the question there itself, right? In any role, 3D metals rise to the maximum at D5, then fall regularly. So when you see the melting point, the graph should come like this. So some exceptions are there, manganese and technetium. Manganese and technetium graph also I wanted to show here. When you see here, it is increased and decreased, isn't it? And manganese and technetium, you can see technetium and you can see manganese, there is a dip in the melting point. So you can see in the lowest melting point of this 3D series is attributed to the manganese because of the D5 configuration. Interelectronic repulsions are experienced because the atom is small. But when it comes to the tungsten, W means tungsten in this 3D, 4D, 5D series, the metal with the highest melting point in the entire periodic table is tungsten. That's the reason why the tungsten is used in the filaments of the electric bulbs. By the way, nobody is using electrical bulbs nowadays, all LCD chal rahe hain. So LED headlights, LED lamps, LED tube lights and everything, I am here with in front of LED lights only. Right, beta? Now, we can also see boiling point of transition metals. The transition elements has high boiling point due to high enthalpy of atomization. What is enthalpy of atomization? Thermodynamics. The amount of energy that given for 1 mole of substance to dissociate into its gaseous atoms. So उसमें atomization में sublimation भी बोल सकता है क्योंकि ये metals है. So this is what A2 is giving rise to A in the gaseous state. So it is endothermic process. So from very strong metallic bond, the metallic bond strength is directly proportional to the number of unpaired electrons. So we can say these parameters are directly proportional to the melting point and boiling point. Do you agree with that, bacho? And moving ahead here, greater फिर भी यही rule है, general rule. Greater the number of valence electrons, stronger is the resultant bonding and higher will be the boiling point. Right? If the metallic bonding is weak, it is going to be low boiling point. So you can take mercury in that action. So you can see again in the same way increased and decreased. 3D, 4D, 5D series. Maximum about middle because D5 तक है, but exceptions भी है. Let's see the exceptions. Electric bulb and LCD is different. Electric bulb is very primitive. Since last 15 years, nobody is using direct electric bulbs. Okay. Now everybody is in LED, light emitting diodes are used. Right? सर थॉमस अल्वा एडिसन बल्ब डिस्कवर किया ना, वो इस्तेमाल किया था. Now moving ahead here, zinc, cadmium and mercury, they have D10 configuration. So as D10 configuration, 0 unpaired electrons and weak metallic bonding and the lowest boiling point and the melting point. Of course, mercury is a liquid at room temperature and these three are volatile. These three are volatile. ठीक है बेटा? Now moving ahead, atomic properties. Good. Atomic properties means there are three major things I just want to include: atomic radius and ionization energies and standard electrode potentials. Let us move here. In this is the atomic radius and 3D, 4D, 5D. So I can see 3D series ka atomic radius is less and 4D series and 5D series. So 5D series is greater than 4D series, but 4D series 5D series दोनों का जो अंतर होता है ना, it is too close, almost similar, बराबर दिखता है यहाँ पर. Yes, of course, Ian. Okay, now you can see here, because of this, zirconium and hafnium have similar properties. Why these supposed to be greater but is nearly similar it is coming? I am wondering why so. Because they experience lanthanoid contraction due to poor screening effect of the involvement of the 4f orbital. Because of the poor screening effect, atomic size compress kiya hoga. And because of this compression, it is going to have almost similar atomic radius, ताकि zirconium and hafnium, niobium, tantalum and molybdenum, tungsten has similar radius, so similar atomic properties. Are you getting or not? Now let us see. Atomic ionic radius values decreases generally and moving from left to right in the periodic table. Yes, of course, and it is decreasing, but you can see in the middle they are going to be nearly the same, and suddenly there is an increment. Suddenly there is an increment. That is the way you have to observe the pattern. Whenever the graph is coming in the NCERT textbook, people see that graph and just leave it, but you observe it, it is decreasing, and up to D5 it is decreasing. After that it is maintaining a similar thing and it is slightly increasing. That is the pattern. Kal jeet gaya India. I already told you, this is Anuj Gupe, Madhya Pradesh, प्यार से. This is a YouTube channel, Sri Chaitanya Academy Infinitel and NEET YouTube channel, and we discuss only concept based and examination based content. So here other things will not be discussed. Fine, I think, hope you understand. Please maintain the chart diagram. Okay, those students, please who are online, please like the session, share with your friends, and I am going to tell you a graph dekhna kaise. And the atomic radius of the elements from chromium to copper are very close. Chromium to copper are very close, you can say, very close, right? And there is a 5D series of the elements are nearly close to the 4D series, hai na? Yeah, Sonali, Gopi, I am just telling you the same thing, you follow this. And this is the thing, up to D5, atomic radius is decreased because effective nuclear charge is overcoming the screening effect. So here manganese, iron, cobalt, nickel का atomic radius बराबर होते हैं क्योंकि nearly constant, because effective nuclear charge is nearly equal to screening effect. And here nickel, copper and zinc, effective nuclear charge screening effect के ज़्यादा, screening effect dominates, and D10 बिकॉज ऑफ द D10 जिंक का साइज सबसे बड़ा होगा. शिवांगी, right? That's the way I am discussing. I will be discussing the density as well. Shivangi, please like the session. And that reasoning is also important. Reasoning is also important. Now, let us say, so from left to right, nuclear charge increases, attraction on outermost shell increases, and electron in n minus d shell also increases. So repulsion between the electrons increases. Screening effect also increases. So the screening effect is the only factor which can explain all the atomic properties and abnormalities in the total inorganic chemistry. Okay, Schottky defect is there in the solid state now, beta. Now it is not. Okay, so solid state is completely out of game here, right? Now let us see, due to Lanthanoid contraction, 4f ऑर्बिटल का जैसे पूर स्क्रीनिंग इफेक्ट का हिसाब से है, ये वाला एटॉमिक रेडियस ऑफ द 5D सीरीज इज लेस देन एक्सपेक्टेड. ओके, that is called poor screening effect, beta. That is what we can say imperfect shielding. So due to Lanthanoid contraction, Shivangi, that's the superb follow up from your side. I love it. Yes. Now moving ahead here, titanium, zirconium and hafnium. So when you see hafnium, there is a 4f14 orbital involvement is there. Because of this poor screening effect, इसको देखना, expected what we think, titanium, zirconium, hafnium, it should be like this, but poor screening effect के हिसाब से ये वाला ऐसे होगा. सो दोनों बराबर देखता है. वैल्यूज बाय हार्ट ना करना बेटा, एंड दिस वैल्यूज कैन इंक्लूड दिस. रीजन इज इंपॉर्टेंट. एसर्शन रीजनिंग इज द बेस्ट क्वेश्चंस इन द नीट एग्जामिनेशन स्कोरिंग करने के लिए, बिकॉज द स्टेटमेंट्स आर ओपनड अप. सो जस्ट यूज योर माइंड देयर एंड डायरेक्टली यू कैन गेट द आंसर. व्हाट डू यू से? I love to do assertion reasoning question. So NTA wanted to test your knowledge and your understanding ability. They are not testing your memory. Fine, that's very important. Now let us see shielding power of the orbitals. S orbital is greater than P orbital is greater than D orbital is greater than F orbital. So as nuclear attraction on the outermost electron increases, size decreases. So that is reason number one. Assertion reasoning के बारे में बात कर रहा हूँ ना. Fine बेटा, right. Now ताकि reason two भी है, drastic increase in the charge increases the attraction, decreases in the radius. That's the reason why titanium, zirconium, hafnium, it is supposed to be bigger, but it is a smaller. So plus 18 increase in the positive charge, plus 32 increase in the positive charge. जब positive charge अचानक से बढ़ रहे हैं ना, effective nuclear charge भी बढ़ा सकते हैं. Are you getting or not clear? That's fine, fantastic. Now moving ahead here, so this is about the Lanthanoid contraction. So what is this Lanthanoid contraction? Definitely I am telling you, you are expected to get a question from Lanthanoid contraction. The steady decrease in atomic or ionic radius in lanthanoid elements from cerium to lawrencium, it is going to be called Lanthanoid contraction. In this Lanthanoid contraction, the reason is the differentiating electron enters into the 4f orbitals in the lanthanides, and this Lanthanides experiences contraction due to just 4f orbitals has poor screening effect. That's the way you can see. General rule. Okay, and you can see the actinoids also. Cerium to lutetium, thorium to lawrencium. Cerium to lutetium, lanthanoid contraction you can see. Thorium to lawrencium, actinoid contraction you can see. So, lanthanoid contraction is due to 4f orbital poor screening effect, and actinoid contraction is also there. This is due to 5f orbitals poor screening effect. But in these two scenarios, I wanted to say actinoid contraction is more effective as compared to lanthanoid contraction. Why? In the actinoid contraction, 5f orbitals are responsible. 5f orbital has poorer screening effect as compared to 4f orbitals. That's the reason why, bacho, it is very important. Actinoid contraction is more significant as compared to lanthanoid contraction. Statement is true. Reason, and 5f orbitals has poorer screening effect as compared to 4f orbitals. Both assertion, reason are correct, and the reason is the correct explanation of assertion. So, Shivam Singh, definitely we can take after atomic properties directly. I'll take into the questions. Hold on. In the next 10-15 minutes, I will start the questions. ठीक है बेटा? Thumbs up? One thumbs up देना यार कम से कम. Right. Okay बच्चों, let us see here. Now ionization energy in the form, in general form, from the left to right in the periodic table, ionization energy in the periodic table is increased, but here ionization energy are super zigzag pattern वाला है. So, due to an increase in the nuclear charge accompanied by the filling in the inner d orbitals, ionization enthalpy increases. Yes, it is true. But here, there are zinc have significantly high ionization energy than copper. Yes. Statement 1 is true. Statement 2. So, find the statements that I am giving you. Arre, don't spam in the chart loop. सर नीट के फॉर्म में प्रॉब्लम आ रही है क्यों? अरे नीट आई विल टेल यू हियर. आई थिंक नीट का जो डेट एक्सटेंड किया ना, अभी देखा आज में नीट का डेट एक्सटेंशन दिया. 3 बजे को आपको एक लाइव चलना है अभी मेरा क्लास के बाद. आई थिंक बीना मैडम विल टेक अबाउट दैट. ठीक है बेटा? सो यू डोंट वरी. So, you can connect with our team, so they are going to guide you in that way. So, in this NEET YouTube channel, we are always connected to the students, and the students are also connected with us. And I can say simply, when you prepare for board, we will be helping you. When you prepare for NEET examination, we will be helping you. When you prepare and got the result, we will be supporting you till your final medical college entry. Yes, I am going to promise you that. Simply you can say, sir, we simply attend the YouTube class, आपको NEET निकलेगा. Yes, निकलेगा बेटा. And आप टॉपर भी बना सकता है. सही सुना आप. Not only clearing NEET examination, you can be a topper as well. Don't you believe that? And since last 2 years, I am taking the classes on the YouTube with the Sri Chaitanya Academy, and many of the students found a very good medical, they got the very good medical seats simply attending the YouTube classes. Yes, it is true. Okay, request a call back, and you can see in the description box, everything is there. Okay, and our SEO made all these things. You can just click Telegram channel and you can click anything. Complete updates you are going to get it. Okay, anyways, you can see zinc has significantly higher ionization energy beta due to completely filled d orbitals. Atom is completely packed. So I mean to say, radius of zinc is greater than copper. Yes, but ionization energy of zinc is greater than copper. But we know ionization energy is inversely proportional to radius. बट यहाँ पर उल्टा चलता है, फुल्ली फिल्ड का स्टेबिलिटी ज्यादा देते हैं. इलेक्ट्रॉनिक कॉन्फ़िगरेशन भी एक फैक्टर है ना. There are so many factors that influence the stability and the ionization energy of the electron. Now you can see you have chemical properties, oxidation state, standard electrode potentials, reactivity, magnetic properties, colors, catalytic properties, formation of interstitial compounds and alloy formation begin. We will see all these properties, जो भी है. Only one thing, these properties are the unique properties of the transition metals is due to simple presence of unpaired electrons in the vacant d orbitals and the presence of availability of d orbitals. All these things comes into picture. Let's see clearly. Due to incomplete filling of the d orbitals, they have the colors. Transition metals show greater variable oxidation states. So manganese different oxidation state में different colors भी दिखाई जाएगा. How to memorize these properties of the all elements? Don't memorize the properties directly, rather Shivangi Singh, you memorize the reason behind the property, right? And you can see manganese 2 plus, manganese 6 plus, manganese 7 plus. Manganese has different oxidation state. Okay, iron 2 plus, iron 3 plus, silver plus 1 plus 2, copper plus 1 plus 2, chromium plus 2 plus 3 plus 6 भी है. Like that variable oxidation state का है. So see this pattern, जब तक D1, D2, D5 तक है ना, availability of the variable oxidation states increased, and whenever the d orbital is getting filled up, getting paired up, availability of the vacant orbitals decreases and the number of oxidation state is also decreased. Sonali, I am not sure how many days, I am not able for how many days you want. Okay. So half filled T2G orbital is more stable as fully filled orbitals. So fully filled orbitals is always stable beta. Manganese shows the highest variable oxidation state, and common oxidation state is +3. And I can be able to see titanium, scandium is the only transition elements do not show variable oxidation state. So many outcomes you can say, so many outcomes you can observe based on this table. Don't by heart it. Write the electronic configuration, you will understand which oxidation state and how it is done. Fine. Now moving ahead here, let us see. Transition elements can exhibit multiple oxidation number. So I am giving you as a statement based. So that statement I made it here, it is a textbook language. Examiner always loves the textbook language, and you have to understand the textbook language, and you have to just identify NCERT बोलना क्या. Okay. Now the most common oxidation state is +2, as the 4s electrons are usually in the first to go. And because of the 4s and the 3d, n, s, n minus 1d electrons are almost close energy. Electrons can move here and here. So the 3d electrons can be easily moved as well. When 3d electrons are coming and participating in the bonding, na, multiple oxidation state be possible हो सकते हैं. Scandium and zinc have least oxidation state. Zinc you don't consider Shivangi because that's not a transition element. It means that can form several ions by losing different number of electrons, can show variable oxidation states. Change in oxidation state of a transition metal will often give rise to color changes during the reactions. That's the reason why iron 2 plus green become iron 3 plus brown, right? So that kind of colors you just memorize it. Manganese pink, copper blue, nickel green, like that. Now, so common oxidation states, scandium 3 plus का, titanium 4 plus का, vanadium 5 plus का, chromium 6 plus, manganese 7 plus. जब D0 configuration आता है, noble case configuration, they are stable. Titanium 4 plus is more stable than titanium 2 plus and titanium 3 plus. So statement type questions. My dear children, just see, this is a statement. That is a noteworthy point. Take a pen and paper and directly write it. क्योंकि टिटानियम 4 प्लस में D0 4S0 इनर्ट गैस कॉन्फ़िगरेशन आर्गन का बराबर और मोर स्टेबल. समझ में आ रहा है क्या बेटा? Any doubt? Please ask if you have any doubts. That's fine. So moving ahead, whenever there is an electron, scandium 4s2 3d1, if it want to exit an electron, it requires a lot of energy to stabilize this. So scandium has showing only +3 oxidation state. So inert pair effect in the p block element we discussed. In that, Shivangi, I am coming to that. Okay. So what is inert pair effect? The inability of the pair of electron ns orbitals do not participate in bonding, so that the oxidation state of the higher p block elements is changed. Okay. So stability order. Okay. Now this is important. Shivangi, I am coming to that. Molybdenum 6 oxidation state, tungsten 6 oxidation state. You can say MoO3 and WO3 are not oxidizing agent. Why? Because they are not oxidation state? Because इसी oxidation state में they are highly stable. And chromium 6, dichromate ion, chromium has +6 oxidation state. In acidic medium is a strong oxidizing agent, because chromium +6 oxidation state is going to be converted into chromium +3 oxidation state. It is going to be more stable. So try to understand, this is less stable and this is more stable. That is the stability order you need to know. The reason I already told you. So p block element I already given you that. Okay, iron, nickel, they have the different oxidation state. Whenever the metal participating a metal carbonyl, its oxidation state is always 0, because due to synergic effect. इलेक्ट्रॉन देते हैं, इलेक्ट्रॉन लेते हैं. सो कोऑर्डिनेशन कंपाउंड्स का कल फिर और एक सेशन लेना चाहता हूँ, उसमें मिलेगा आपको. सो लोअर ऑक्सीजन स्टेट इज फेवर्ड बाय द मेटल व्हेन अ कॉम्प्लेक्स कंपाउंड हैज लिगैंड्स. दैट्स अ वेरी इंपॉर्टेंट पॉइंट बच्चों. And which are not just a strong sigma donor but also pi acceptors. That is what is called as a synergic bond. Remember? And also see in the group halides in the 3D, when you see a metal can show its highest oxidation state when it forms a fluoride or oxide. So these are all the halides, lower halides and higher halides. Higher halides में highest oxidation state होगा more covalent. Lower halides में lower oxidation state होगा more ionic. Fazan rule का हिसाब से बेटा, Fazan rule का हिसाब से. Now you can say fluorine stabilizes the highest oxidation state. So the stability of the highest oxidant state could be by two reasons. So COF3, it is more stable due to high lattice energy and higher bond enthalpy. So VF5 CRF5. सो हायर ऑक्सीडेशन स्टेट का जो रीजन आता है ना वो भी काफ़ी इंपॉर्टेंट है बेटा. And also you can see instability of copper to iodides. This is a so dangerous concept. So I mean to say CuI2. Okay, Cu2 oxidizes I minus to I2 doesn't exist because it is going to be reducing agent, it is going to be oxidizing agents. दोनों साथ कैसे रहेंगे? They cannot stay together. So they are going to get Cu2 I2 plus I2. So iodine is going to be disproportionated. Copper Cu2 I2 is formed. Cu I2 never exists, rather Cu2 I2 exists. Reasoning भी काफी important है बेटा. And you can see the ability of the oxygen to take the metal into the higher oxidation state, because oxygen has the ability to form multiple bonds. Because of these multiple bonds, the bond is going to be stabilized. You can say Mn2O7, MnO4. Array, this structure, this 2026 January shift में JEE में एक क्वेश्चन पूछा, right beta? It has multiple bonds. It forms p pi and d pi multiple bonds beta. P pi and d pi multiple bonds, which makes it is more stable. Transition metal vary widely in the chemical reactivity. That is done by using the standard electrode potentials. Fine beta? Very good. Now look at this. Standard electrode potential measures the equilibrium potentials. So standard reduction potential, electron taking process is a reduction, and the potential that you experience is a standard reduction potential. S or P electrochemistry में हम देखा. And you see directly I want to show you, there is always, you see, all zigzag is coming, but the thing is copper. So the copper, when you see the values, it is going to be positive value. सबका negative value होता है. Jenna, tell me whatever you doubt. And every metal has its own values, and copper का जो है ना, copper 2 plus and copper and electrode potential का value है ना, it comes to be positive 0.34. Why this is positive? Because this has a high hydration energy. So the hydration energy compensate the ionization energy too. Statement based questions are important, as I am telling you. So that can be given here. Okay, in +2 oxidation state, manganese shows D5, nickel has D8, has completely filled T2G orbitals. आप बोल रहे हैं ना? Right, Shwangi. And zinc has completely filled D10. That's a different scenario. So they show the more negative values than the expected. All are having negative values, but copper has only positive value because it has a high hydration energy compensates the second ionization energy. So magnetic movement के बारे में बात करना चाहता हूँ. So transition metals and their ions has magnetic moment, and a substance can be magnetized, okay, can be deflected in the external magnetic field if it has unpaired electrons in its electronic configuration. Okay, mouse me Zena, if you have any doubts, so please ask us. And orbital angular momentum के हिसाब से spin only magnetic moment is equal to root over n into n plus 2, and where n is equal to number of unpaired electron. If n is equal to 0, then mu is equal to 0. We can say such compounds are not magnetized, so they are called as a diamagnetic. They are said to be diamagnetic, right? If you have, if n is not equal to 0, mu is not equal to 0, I mean it is a positive value, so they are said to be paramagnetic. The unit आता है पर bm, Bohr magneton, unit is Bohr magneton. And moving ahead, Mn2 plus, so 3d54s0, it has 5 unpaired electrons, mu is equal root over n into n plus 2, so root over 5 into 5 plus 2 and 5.92, Bohr magneton. In the Telegram channel, the link is there and you can just click it and join. So सारे का सारा notes in the PDF form में आपको मिलेगा बेटा, ठीक है. Now moving ahead, the transition metal ions can show colors, various colors. I could not get the point of titanium plus. कौन सा point है बेटा? Okay, let me finish this. शिवांगी. Electron configuration लिखेंगे तो आपको पता चलेगा. Stability, ionization, energy, everything. Okay. Now, let us talk about the colors. When I say chromium 3 plus, green, manganese 2 plus, it is pink. Screen में नहीं दिख रहे हैं ना, pink. Okay. Iron 3 plus, brown, and cobalt 2 plus, purple, and copper 2 plus, blue, like that. Okay. And why do they have the colors? Because of the presence of unpaired electrons in the d orbitals. The d orbitals actually has degenerate 5d orbitals. These 5d orbitals in the presence of an anion ligand is going to split into two set of orbitals, T2g and Eg orbitals. अगर अनपेड इलेक्ट्रॉन होगा तो इलेक्ट्रॉन एक सेट ऑफ डी ऑर्बिटल से और दूसरा सेट ऑफ डी ऑर्बिटल का जंप करना चाहता हूँ बाय एब्जॉर्बिंग ए कैरेक्टरिस्टिक वेवलेंथ इन द विजिबल लाइट, ताकि इसका कॉम्प्लीमेंट्री वेवलेंथ ट्रांसमिट किया जाएगा. सो दैट ट्रांजिशन मेटल्स शो कलर्स. दैट इज व्हाट इज कॉल्ड एज अ डी ट्रांजिशन. इन दिस complex formation is also very important. Complexes are the compounds formed by the association of the transition metal and the ligand. So इतना ligands पैक करके रखने के लिए ये central metal atom को maximum what we say effective nuclear charge होना चाहिए. High nuclear charge and presence of vacant d orbitals are the responsible factor that can show the transition metals to be colored. Okay, and also formation of a complex compound, reason for the complex formation beta. That's good. Here, comparatively smaller sizes, high ionic charges, and availability of the d orbitals, anything can be. Statement 1 and statement 2 based questions are important, about 45 questions mein. Shivangi, due to dd transition and the charge transfer causing colors. Charge transfer phenomena is the one which is very important, just phenomena. Potassium permanganate, intense blue, intense purple in color. Dichromate. So these are all due to charge transfer phenomena. What you say is very true. And the transition metals show catalytic property due to availability of again vacant d orbitals, and also they have the variable valencies. So they form complexes. So whatever the reason. So anyways, the entire story move here and there and come and stop at d orbital only. Right, beta? Now let us see. Iron 3 catalyzes the reaction between iodide to iodine. So Fe3 plus is a catalyst. You can use FeCl3 as a catalyst. So catalytic action का जो mechanism है अभी इतना ये समय में इतना important नहीं है क्योंकि catalytic theories are not here. Okay, बच्चों, now formation of interstitial compounds. So this is a metal lattice जो gap होता है ना okay, that is called interstitial site. उसमें स्मॉल नॉन मेटल एटम्स like कार्बन, बोरॉन, हाइड्रोजन अटक जाएगा. They are called interstitial compounds, and these interstitial compounds ऐसा appear like this and they don't follow stoichiometry, but they have the different properties beta. Let's see the different properties. The transition metals higher than those of pure metals, high melting point and boiling point, interstitial compounds का जो properties है. And some borides approach diamond like hotness, very hot, and retain metallic conductivity फिर भी, and chemically inert, that's very important point, right? बच्चों, like that we have various things, okay. So we will discuss tomorrow. We have another session, compounds भी देखना है, and after that Shivangi, I'll come across with questions tomorrow, some compounds K2Cr2O7, KMnO4 will discuss, right, and some questions also, right. Now students, hope you enjoyed this class, and please like the session, share with your friends, and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. Thank you very much. Signing off, Dr. Suresh, Faculty of Chemistry. Thank you.